Here, let me use an example to illustrate. Packet switching actually outperforms circuit switching when there are more users and each of these users are not exactly very active, sending short messages only each time. All right, so scenario is very simple. Okay, we do have a network of end users and they're behind this router. Going out of the router is a very low bandwidth link, 1 megabits per second. And each of the user is behaving this way. When they're active, they do need a lot of bandwidth, 100 kilobits per second. But they're only 10% of the time active. In a circuit switch network, in order to satisfy these 10 users, and each at maximum requires 100 kilobits per second, so we reserve 100 kilobits per second to each of the users. And how many users we are allowed to reserve bandwidth? This is 1000 kilobits, so we can only allow 10 users, okay, 10 circuits. But in packet switching, you see, the users are only active at 10% of the time. Consider this scenario. If we have 35 users, right, the only situation that these 35 users will have trouble sending data out is when there's at least 10 users being active at the same time. So what is the probability of these 35 users and more than 10 of them being active at the same time? If you do the calculation, you'll see that it's very low. So 99.9996% of the time, in packet switch network, 35 users will do well. No trouble. So if you do have a lot more users and each of the user needs just a small portion of time to send data, which one would you pick? Circuit switching or packet switching? It's quite obvious, isn't it? And oh, by the way, anyone here knows how to derive this value? The probability of 10 of the users being active at the same time, given the active rate is 10%.